In order for us to solve log equations, there are a few different methods that we can use. One of them will work in all problems, is for us to get all the logs on one side of the equal sign, get all the rest of the values on the other side, and then convert from log form into exponential form. We may need to condense the left side where the logs are before we can do that, and then directly solve from there. So for this problem, here's what I'm looking at. I see that we have just one log term here. It is all by itself over on the left side of our equal sign already, so I'm ready to convert this into exponential form. In order for us to go through and do that, there's a couple of different ways of thinking of that. Excuse me. One of them would be for us to use one of the properties of logs, and the property that we would use would be this one. If you have b and it is raised to the log base b power, so the base of the log, which is up in the exponent, the base of the log is b, and also the base of the exponent is b. All of those things cancel out, and we just end up with x. We have a log base 6 right here. So what we can do is we can rewrite the left and the right sides of the equal sign as exponents, and we can choose whatever base we want. We just want it to match, though, whatever the base of the log is. So the base of the log here is 6. So when I rewrite this, I'm going to write it as 6 to the log base 6 of 2x minus 1 power equals 6 raised to the negative 1 power. The left and the right sides of the equal sign here are going to become exponents. So we would have 6 raised to the log base 6 of 2x minus 1 power, and that is equal to 6 to the negative 1 power. So if you look, the left and the right sides are now exponents, and I've rewritten both of those with a base of 6. That's called exponentiation. You can do that anytime in any equation to solve. You do have to do it on both sides of the equal sign, and these bases, whatever you use here, have to match. They can be anything, but they have to match. And I chose 6 because we have log base 6. So now if you take a look, we have log base 6 up in the exponent. The base of the exponent is also 6, so we can use this property, and what we will get in the next step is just the x. The 6 and the log base 6 will cancel out, so we're going to end up with 2x minus 1 is equal to 6 to the negative 1 power. 6 to the negative 1 power well, that's the same thing as 1 over 6 to the first power. And if I go through and solve, 1/6 plus 1 would give us 7/6 if we write that as an improper fraction. I could divide both sides by 2 here, but if I do that, I'll have a fraction divided by something, so it would be better instead of dividing by 2 to multiply by its reciprocal. Remember, anytime you divide, you could write it a different way by multiplying by the reciprocal. Dividing by a number is the same as multiplying by the reciprocal. So instead of dividing by 2, I'm going to multiply both sides by its reciprocal. And the reciprocal of 2 is 1/2. 1/2 times 2 gives us 1, so we'll have 1x. And then on this side, if we multiply straight across the top and the bottom, we would have 7/12 for an answer on that. So x is equal to 7/12. Another option when you're going through and solving equations with logs in them is for us to go through and taking a look at the logs, get all the logs on one side and condense. If you go through and do that, you will be able to solve. It isn't always the fastest way to solve, but it does give us one method that will work on every single problem. So I see in this problem we have two logs. The base of the log is not written in at all, so I know this is log base 10. So this is 2 times log base 10 of x is equal to log base 10 of 4. What I'm going to do is I'm going to get all of the logs on one side of the equal sign. I'm going to do that by subtracting a log of 4 on both sides. That would give us 2 times log of x minus log of 4 is equal to 0. And then from here, we can go through and we can rewrite this using properties of exponents. So if we go through and use our properties, what I would like to do is I would like to have just one log written here. And to do that, I need to first take any coefficients we have in front of the log and write them as exponents. So the 2 that's out here in front, I can write as an exponent with the x. So that's going to be the log of x squared. That second term didn't have anything in front, so I don't have to do anything with that one. And now, using another one of our properties, if you have a log minus another log, you can rewrite that with just one log. This first log is positive, so the x squared would be in the top. The second log has a subtraction in front of it, so the 4 would go in the bottom. Now I have one single log isolated over here on the left side of the equal sign. From there, I can rewrite this without a log at all. So again, what I'm going to do next is I'm going to exponentiate both sides using this property again. If you have a value and that value is raised to a log power where the base of the log and the base of the exponent are the same, the base of the exponent and the log cancel each other out, just giving us that value of x. So for this problem, I have a log here. There's no log written in, so I know it's log base 10. So what I'd like to do is I'd like to rewrite this using 10 as the base of my exponent. So again, here's my previous equation. If you look at the left and the right sides, those are now exponents, and I've chosen a base of 10 because this is log base 10. Now those will cancel out. On the right side, I do have 10 to the 0 power, and anything to the 0 power is equal to 1. Now I can go through and solve directly. I have x squared over 4, so to get rid of that 4, we'll do the opposite operation and multiply both sides by 4. That would give me x squared is equal to 4. And to solve that, I am going to need to do the square root on both sides. Remember, when you do the square root on both sides, you do need to remember the plus or minus. So there are two possible answers to this. X is equal to plus or minus 2. We do have some restrictions with logs, and if you remember correctly, you can only take the log of positive numbers. You can't take the log of negative numbers. So I want to make sure that these two values here that I came up with will work for this problem. I want to take 2 and negative 2 and plug those in and see if they work. If I take 2 and I plug that in for the x here, I'm going to end up with 2 log of 2 equals log of 4. And when I plug that in, what I end up with here is log of a positive number. So 2 will work. But if I take negative 2 and plug this in, I'm going to have 2 times log of negative 2 equals log of 4. And we can't take the log of a negative. So we have 2 possible answers. And if you plug them back in, negative 2 will not work because we can't take the log of a negative. So the only answer to this one is simply 2. You can go through and plug those in and evaluate that on your calculator. That would be totally fine. Your calculator would give you an error on that. Or you can eliminate that as a solution by visually plugging in those values. If I checked my work, it would look like this. First, let's see if x does equal 2. If I plug 2 back up here for the x in the original, I would have 2 times log of 2. I want to see if that is equal to log of 4. This is log base 10, so I can just use my calculator and plug that in. So I have 2 times log of 2. So there's the left side there. If you look at that decimal, it's about 0.602. I did round that off to a couple of decimal places there. And I want to compare that to log of 4. And if you look, those values are exactly the same. So for sure, x is equal to 2. That does check. I also want to do the same thing and see if x is equal to a negative 2. So taking negative 2 and plugging that in for the x up here in the original, we end up with 2 times log of negative 2. I want to see if that is equal to log of 4. I already know what log of 4 is. That's approximately 0.602. I've evaluated that already. And now I'm going to plug this in to my calculator. So that's 2 times log of a negative 2. And if I evaluate that, my calculator does say non-real answer. There's an error there. And again, the reason for that is you cannot take a log of a negative number or 0. You can only do logs of positives. So for this problem, x cannot equal a negative 2. So again, if you understand that that's how logs work, you can plug that back in and recognize that out of our 2 possible answers here, a negative 2 wasn't going to work. And our only answer here is 2.